All right, we're going to talk about section 3.1 from Algebra 2, and that's solving systems by graphing. We need to understand what a solution is for a system of equations and how to find it by graphing the system on one graph. So, first thing we should look at is, well, when you graph two lines on the same graph, what could it look like? Well, there's a couple different ways. There's really three main ways it can be. The first way is the obvious one. Well, one goes one way, the other goes another way, and they eventually hit each other and they intersect. That is the most common way that they're going to have. It's going to be where they go and they hit at exactly one point. The next way to think about it is, well, if I have one graph that goes right there and I have another graph that goes right on top of it, well, what's going to happen with those? How many solutions are those going to have? How many times do those intersect? Well, it's kind of less obvious, but it's infinitely many times, right? If it's on top of each other, then it's going to be all of the points are the same, which means they infinitely hit each other and they're right on top of each other. All right. The last way we're going to talk about is, well, what if I have one that goes up this way and I have another one that goes the same direction and they never ever hit each other? Well, those are going to have no solutions. It's not going to actually intersect each other. Those are parallel lines. When they're parallel lines, they don't actually hit each other. All right, well, let's go back and let's think about what does it mean to be a solution for a system of equations? Well, what it means is, does the point work for each equation? If the point works for each equation, then it is the solution for the system of equations. Remember, a system of equations, that means multiple equations. And so if the solution works for both, well, then it is a solution for the system. If the solution only works for one of them, then it's not a solution for the system of equations. So, when we're asked, is this a solution for the system of equations, all we have to do is plug it in to figure out. So, does it work for the first equation? Let's plug it in. Is 3 plus negative 1 equal to 2? Question mark. Yeah, this ends up being 2 equals 2, so that works. But now we have to check it for the second equation as well. It cannot only work for one, it's got to work for both. So we have to do 2 times 3 plus negative 1. Does that equal 3? Well, 2 times 3 is 6, and minus 1. Does that equal 3? Well, no. It's 5 equals 3. That doesn't work. So no, this is not a solution. This is not a solution. So the key to this is make sure you don't just stop once you see that it works for one equation in the system. It's got to work for both equations in the system. Because it doesn't work for that blue equation, it is not going to be a solution for the system of equations. All right, I want you to pause right now and I want you to try this second one on your own. Tell me, is this a solution for the equation or for the system of equations? All right, here's what I got. You should be able to check and see that it definitely is a solution for the system because it is a solution for both of the equations. Now we're going to learn how to estimate the solution by graphing. So the first thing we need to do is we need to actually graph each equation. So I'm going to graph y equals 5 halves x plus 5 in purple. And there's the graph. I'm going to also graph the point or the line 2x minus 4y. I'm going to graph that in red. And here's my second graph. Now, to check for the solution, you need to find the point that works for both equations. I'm guessing you guys are sitting at home and you're realizing where that point is. Well, it's the point where they actually cross each other, where they intersect each other. This right here is the point that is the solution to this system of equations, okay? So what we have to do now is figure out what that point is. Well, we count. Now we just count. We're going left 4, so it's going to be negative 4, and we're going down 1, 2, 3, 4, 5. So my solution to this system of equations is negative 4, negative 5. Now, I don't know if that's exactly it because I'm graphing and, there's human error, but I'm guessing that that's the point. Now, the way to figure out really does it work, let's plug it in and test it. Does it work for both of them? So negative 4, 5. I'm going to plug that in up here. So it's negative 5 equal to 5 halves times negative 4 plus 5. I'm going to do some math here for you. And you end up getting negative 5 equals negative 5. That works. All right, now I'm going to try to my second equation here where we have 2 times negative 4 minus 4 times negative 5. Does that equal 12? Well, we get negative 8 plus 20, so you're going to get 12 equals 12. Well, you can see now that we tested it, this is definitely our solution. So this is our solution to this system of inequalities. Or sorry, not system of inequalities, system of equations. Now let's try this one. I'm going to graph the first line. I'm going to graph it in green for you. And there's my graph. And I'm going to graph this next one. Let's go with this one being yellow. It's going to be kind of hard to see, but you'll see why I'm doing it in yellow in a second. I'm going to graph that one in yellow. Now if you guys look, I made my green line a little bit thicker because I put the yellow one up there, and you can see that it's right on top of it. If you notice, that means that there are infinitely many solutions, and that means that this is a system that has infinite many solutions. That means that this is a consistent, independent system of equations. When we have, go back to the last one we had where we had one individual exact one solution, that's a consistent and independent, and this one is a consistent and dependent. Did I say independent? I meant to say consistent and dependent. So this is consistent and dependent. This is consistent and independent. It's independent because they go in different ways. This is dependent because it's the same line. It's just changed a little bit. So infinitely many solutions. All right, let's try another one here. Again, I'm going to graph this first one. I'm going to graph that one. It's purple, so y equals negative 3 halves x minus 4 is going to be purple. All right, there's that equation. Now I'm going to graph the next equation. I'm going to graph that one in, well, let's go with red again. So I'm going to graph that one in red. All right, there's the graph of my second equation there. You guys can see that the solution for this is about right there, which is about negative 1, 2, 3, 4, 5, negative 5, negative 3. I could plug it in to test it, but that's about where it is. All right, I'm going to leave this example for you guys to do. I want you guys to graph it and give me the solution to the system, and I'll come right back with the solution. All right, our solution should be negative 1, 3. So that's all we're doing for section 1 or 3.1 is that we're going to graph these. So make sure you guys are practicing getting it done. Make sure you know how to do it, and make sure you can find the solution or estimate the solution from graphing.